Lishba, and recently I've been looking into tissue engineering and nanotechnology to create organs. Pretty cool, right? But the issue itself is a growing problem. The shortage of organ transplants has been very stagnant because of long wait times. Also, most of the organs and solutions that are coming out are not effective in the body. So, what if there was a way for doctors to just construct a new organ using a small number of cells from the body of the person with a defective organ? This would reduce the waiting time, also eliminate any risk of organ rejection because the new organ would be coming from the person's own tissue. I researched a way for us to be able to do this using tissue engineering and nanotechnology, which is developing and studying materials that function within the nanometer scale. Basically, we could be taking a tissue sample from the body, growing the cells from the sample into new tissue, and then implanting this artificial tissue back into the body. Tissue is a fundamental building component of all human bodies. It is a group of similar cells that have a defined function. These cells can be of the same type, but different in size and have different functions. Each tissue consists of two components. There's the cellular and the extracellular matrix. Everything you see on your body is made up of some type of tissue. For example, our heart is just muscle tissue. When we cut ourselves, we feel pain through our nerve tissue. And blood is basically just a type of liquid tissue. When we do put a fake tissue in our body, it's actually really smart, and our body is able to recognize that something is different. And then your body attacks the tissue as if it would for any other disease. And the nanofibers are actually really helpful in this situation because they're very similar to extracellular matrix that makes up a lot of the tissue. The matrices are basically just mechanical support for the tissue. It enables the cells to be attached and regulates division, migration, and the shape of the cell. Cells grown on the nanofibers are also a bit cheated because they act naturally, so we are able to create new tissue successfully. We can also use patient cells, cultivate the tissue, and then place it into the desired place. Cells work on nanofibers because they're so delicate and tiny that the cells are really easily adaptable onto it. So basically, the more secure the cell, the faster it will reproduce the cells, which is really good because that just grows the production of the tissue. Then the structure that this happens on using nanofibers is called a scaffold. After it fulfills its function, it basically breaks down or can also serve as food for the cell. So we can use a method called electrospinning as a scaffold fabrication method. Electrospun nanofibers can basically improve the cell adhesion and growth and direct the movement of the cells. You use an injection pump, a syringe, a needle, a high voltage power supply, and the collector plate. The polymer solution is pumped to the tip of the needle. An electric field is created between the tip of the needle and the collector plate by applying high voltage. When the surface tension in the liquid droplet is gone by the force of the electric field, the droplet distorts and becomes a tailor cone. The distortion leads to an electrically charged jet ejection that moves towards the collector, and then that forms the thin fibers. Since this material is basically rotating, this basically just creates even more aligned fibers. That's pretty much how this tissue is created using nanofibers. I'm so confident that in the next decade or even less, we will be able to create these organs really, really effectively. And since these created organs are very similar to the original tissues, maybe they can even be used to test drugs and other treatments without any risk to human health. That's it for me. Thanks so much for watching. I'm so excited to work in this industry and do even more research, and I can't wait to share all of this research with you over the next few months. Thanks so much for watching.